So this recording is to help you calculate the root squared error in calculations where you're multiplying things together or you're dividing them. I've put the formula for the root squared error over here in this box on the right. So let's do an example to see how it works. So let's start off with a sum of the kind A equals B times C. So B, let's say B has got the value of 10 and an error of plus or minus 2 in it. Let's say that C has got the value of 25. The error in that is 3. So this is B, this is delta B, this is C, this is delta C. So the fractional error equals the absolute error divided by the value. So the fractional error in B is 2/10, which is 0.2. And I can drag that formula down to get the fractional error in C, which is 3/25, which is 0.12. What I need to do over here is to square those values. So I type in equals D5, then I use a hat symbol and a 2, which means to the power of 2. Hit enter, and it gives me the answer. Drag that down. So the squared fractional errors, delta B over B squared, delta C over C squared. So let's think about A. So A, value of that is simply B times C, press enter, 250. The squared fractional error is simply the sum of the individual fractional errors, like that. Because if you think about this equation here, if I take A over to the other side and then square both sides, I end up with delta A over A squared, which is the fractional error in A, the squared fractional error in A. And on this side I have squared fractional error in B plus the squared fractional error in C. So the sum of the individual squared fractional errors is the fractional error in the product squared. So to find the fractional error, I need to take the square root of this value here. So I do equals square root SQRT of that cell there. Press enter. So I now have a fractional error in my product of 0.233. So to find the absolute error, I multiply the value that I have by the fractional error. It's 250 times that there, 58. So if I'm multiplying 10 plus or minus 2 by 25 plus or minus 3, the answer is 250 plus or minus 58. Quite a lot. Let's do another example. In this case, we're going to say A equals B divided by C. And let's say that B is 6, an error of 1. C is 2, with an error of 1. So I can calculate the fractional errors. Fractional error in B is 1/6. Fractional error in C is 1/2. And then if I square those, get those values there for the squared fractional errors. And this means that the squared fractional error in A is simply the sum of those two numbers. So the fractional error in A equals the square root of that. The value of A is 6 divided by 2, which is 3. So the absolute error is the value times the fractional error. In this case, 1.58. So if I do 6 divided by 2, and there's an uncertainty of 1 in each of those numbers, then the answer I get is 3 with an error of 1.58.